Hi, I'm Wayne Lack and I'm doing January 2013 Core 3 paper for AQA. We're now on question 5 and the examiner's report here says in part A, well overall actually there's a few misunderstandings. This question is particularly mean in minor details. They get you the mark, so you need them to get the mark, but they're minor details, so a lot of candidates overlook simple little things, and I'll just, rather than reading out all the mistakes people could have made, I think I'll just go through it in the question. But the examiner's report says even the strongest of students, the strongest candidates, some of them did make these sorts of errors, these little tiny things. So I think better than reading out a long list is just to go to the question, and I'll talk about them while we're there. So let's go to the whiteboard. Alright then, question 5. You might not be able to read it very clearly, so I'll read it out now. So, question 5, f of x equals x squared minus 4 over 3 for all real values of x where x is less than or equal to 0. So there's an A, there's a B and there's a C, but C altogether would take up so much room, so we're going to do C on the next whiteboard. So here's A and B to start with. So A is state the range of f. So state the range of this f of x. So what it wants you to say is firstly f of x. Now that's one of the examples of the mark that a lot of people omit. You might have been tempted to just put f or just put x, but they want f of x. Then they want an inequality sign. So the question is it greater than it or is it less than it for the range? Now this is a quadratic of some description. It's got an x squared in it. And it's a positive x squared, so just think of a U shape. It's translated, you might even think, what does the graph look like? But it's a positive shape. So when x is less than 0, but it's going to be increasing at some description. It's not going down, it's not an N-shaped graph, it's a U-shaped graph. And so it's going to be greater than or equal to 0. And most people did get that just by thinking about what's going to be happening at that point. We put this value of 0 into here, because that is our domain. We put that into here and we can find the range. So when x equals 0, we've got 0 minus 4 over 3, which is just minus 4/3. That probably would have been accepted as a decimal. I'm going to leave it as a fraction. So f of x is greater than or equal to minus 4/3. So a lot of people said f rather than f of x. That's a simple little mark there. They need to see f of x. Minus 4/3 was generally given well, and the inequality sign being the wrong way round was actually quite common. So B part 1, the inverse is f to the minus 1. What is the domain of this f to the minus 1, this inverse function? Well, the domain of the inverse is the range of the original, but domain, rather than saying f of x, we say x, rather than f of x. X is greater than or equal to minus 4/3. So it's just what you did in the first question, but it's x in place of f of x. And then there's B part 2. Find an expression for f to the minus 1 of x, the inverse function. Find an expression for the inverse function. So what we have is we sort of have y equals x squared minus 4 over 3. And how we can think of doing this is swapping around the x and y and then solving for y. So x equals y squared minus 4 over 3. And eventually these y's, I mean the y here is f of x, and at the end the y is going to be f of x. So you could just do f of x, but it's just easier to write y while we're rearranging it. So first thing, you times by 3, so we get 3x equals y squared minus 4. So then you plus 4 and square root it. Now when you square root it you get two values, so we get y equals plus or minus the square root of this 3x plus 4. And now the challenging part comes from saying, well, is it the positive or is it the negative version? Now this, we look up here for our hint, it's the domain of the original. That x is less than or equal to 0. If it's less than or equal to 0, it's going to be the negative one of these. So we change the y for f of x, and it's the negative root 3x plus 4. Okay, so if you have a choice between the positive and the negative, which you normally do with these questions, look at what it's restricted to start with, if it's going to be a positive or a negative root, because you can't square root a negative. So no matter what this is, no matter whatever the x values is, if this came out to be negative, then that wouldn't be real, it wouldn't exist at that point. So whatever the square root is going to become positive, and we can't have positives because of this x being less than 0. We can't have y equaling some sort of positive, so it has to be the negative in front of the square root, so that no matter what the square root comes out to, it's going to become negative anyway, so it's less than 0. And in terms of marks, this is 2 marks, 1 mark, 3 marks. So 2 marks, this f of x is important, and then the equality sign being the right way round. This one most people were fine with, the domain of one being equal to the range of the other. Most people were fine with that. Question 3, some people didn't know what to do, this exchanging the y and an x, but most people didn't know whether to do the plus or minus. A lot of people just gave 2 answers, which is wrong. They want the minus answer for all 3 marks. Most people, nearly every candidate gained the 2 marks here, but a lot didn't gain the 3rd. So let's get on to part C for the rest of question 5. Okay, so I think you can just about see it, but I'll read it out anyway. G of x, another function of x, equals natural log of mod 3x minus 1 for all real numbers where x does not equal a third. There's a quick sketch of it here. Here's the point P. It draws all of this in your exam. So C, part 1, find the x coordinate of P. So the x coordinate of P, this crosses the x-axis, as you can see, at 2 points, but both of these points are going to be when y equals 0. So what we're doing is we're setting natural log of mod 3x minus 1 equal to 0. That's what we're doing. So we exponentiate both sides. We get the modulus of 3x minus 1 equals e to the power of 0, and anything to the 0 is 1, so it's 1. To get rid of the modulus, we then have 3x minus 1 equals plus or minus 1. That's how we get rid of a modulus. So hopefully you can see that if we take the minus option first, if it's minus 1, you take the 1 over there, that becomes 0, and then you divide by 3, you get 0, so that gives us that point there, the origin, when x equals 0. So we're going to take the positive value of 1 to find the other one. Take the 1 over, you get 2, divide by 3, you get x equals 2 over 3, 2/3. Or you could convert that to a decimal if you really wanted to. So find the x coordinate of P. We don't need a y coordinate because it says in the question x coordinate, and that's that done. Part 2, state whether G has an inverse, and then it says explain your answer. So does G, which is drawn here, does it have an inverse? The answer is no. And your reason, G of x is many to 1, or G of x is not 1 to 1. And you can see that from this sketch. One y value could give 2 possible x values, so it's many to 1. And only 1 to 1 functions have an inverse. That's just something you need to know. So part 3, show g f of x equals natural log of modulus x squared minus k. You've obviously got to show the value of k. So I'm going to have to remind you, because I had to do it on 2 different boards, what f of x equals. So f of x was the first function we dealt with, which is x squared minus 4 over 3. So to find g f of x, you take f of x and you put it into g in place of all the x's. So g f of x equals the natural log of modulus, looking good so far, 3 lots of, and then our x is our f of x, which is x squared minus 4 over 3. Then you're going to have this minus 1, because that's there. Now if you times this by 3, it's going to cancel with the 3 on the bottom, so we're going to have the natural log of modulus x squared, and we're going to have minus 4 minus 1, which is minus 5, because the 3's cancel and you've got minus 4 minus 1, which is minus 5. And that is in the form we want it to. So k is -5, you might want to state that, but it's not necessary as long as you put it into that form. Finally, part 4, solve g f of x equals 0. So we've just done g f of x, what that equals, and it tells you anyway, but we've just done this, so x squared minus 5, we've set it equal to 0. So first we exponentiate both sides, we get the modulus of x squared minus 5 equals 1, e to the 0 is 1. So we get this x squared minus 5 equals plus or minus 1. So then we plus on our 5, but we plus it onto both minus 1 and 1, so we're going to get two values for x squared. So x squared equals both minus 1 plus 5, which is 4, and plus 1 plus 5, which is 6. So then when we square root, we get plus and minus again. So for x, we actually get 4 values. We get root 4, which is 2, minus root 4, not root minus 4, minus root 4, so that's minus 2, root 6, which I don't know, is just root 6, and minus root 6. So we actually get 4 answers there. But it said right at the beginning for the function of f, it said its domain is for when x is less than or equal to 0, and these are x values, and x has to be less than or equal to 0. So we can then go on to say, as a final answer, that x actually, of these answers, only equals minus 2 and minus root 6. And you could specify why. You could say, right back in the beginning of the question, it said x is less than or equal to 0, so you could specify that's why you're getting rid of this 2 and root 6 and keeping only the negative values. It's up to you, but these are your two answers. So in terms of marks, this was 2 marks. It's just rearranging it correctly. This is 1 mark, it's just a statement really, many to 1. It's just one of those things you have to know. This is 2 marks again for rearranging, and this is 4 marks because you've got to do a bit of rearranging. You get 4 whole answers, but then you have to omit 2 for further marks to get these just 2 on their own. So altogether, this was a very hefty question. Hopefully this has helped you at least a little bit. I'm going to see you at question 6 next.